Hello everyone and welcome to aga-cad's webinar, The Best and Fastest Way to Start Framing in Revit. My name is Eve and I am a BIM application engineer here at aga-cad. We create applications for Autodesk Revit based on the needs of world's leading BIM practitioners, and we eliminate tasks that do not create value. We've developed the widest range of true BIM software in the world for Revit professionals, covering wood and metal framing, precast concrete design, and MEP system design. Today I'm going to talk about how to start framing on an empty project using our BIM solutions for wood and metal framing. Starting out only with basic Revit elements, walls, for example, the result you'll see are multi-layered walls fully framed for prefabrication or on-site construction. Additional layers of sheathing, nailers, and other will also be added. All panels and structural members will be automatically sorted for shop ticket generation, and if you're a new user, this webinar will be a great opportunity to see the workflow from the very beginning so you can start working on your own project with confidence. And if you're an experienced user, you'll see the essential step to solidify the process with which you're already familiar. I will start from creating a new project in Revit and show you the modeling recommendations to create the architectural project before starting to frame. So I will open Revit and I will create a completely new project from just a standard Revit template. So in this project, I won't have any wall types, any families loaded, nothing like that. So you may start from your own template as well. And as you may know, before framing with our software, you have to have the model already created in Revit. And then with our software, you will distribute structural framing elements in the model. So I will start off by drawing a few walls. And in this project template, I don't really have any walls that would be suitable. So I will take a wall from Revit, I will rename it. It's just a wall from Revit's template, and I will modify the structure of the wall. So it's very important, the structure of the wall, because later we will be able to map framing configurations to each of this layer. And there are no limits to how many layers you can have. You can have 10 layers and frame them all. You can frame only one layer but have more layers. It completely depends on your own standards and what you need. But there are basic things that we recommend. So first of all, we recommend to have only one structure layer that would be added inside the core boundary, and then you can add as many layers as you need to the exterior and to the interior side of the wall. So I will add, let's say here, the nailers. Then I will remove this layer, and here I will have, let's say, maybe here I will add sheathing, and here I will add nailers, and here I will add the siding. So in this layer, I will have, for example, also nailers, and here I will have another layer of sheathing. And another thing that is important is that you would have a material assigned to your layer. So what I will do, I will just browse through standard Revit materials and assign them to my walls. And another thing that is important is that the material would have a density parameter value, then the mass will be calculated automatically. So I'll keep this one for the sheathing, and here I will have another layer of sheathing as well, so I will paste that. Then I will add some materials right here. Maybe here I will just use the same one and a material for the siding. Okay, so these are my materials, and now it's important that I would also add a correct thickness, because then I will be able to automatically assign all elements based on the layer thickness that I create in Revit. So there it is, I've created the wall structure. Now I can save it, and I have a wall for the exterior. And now I will edit this type of my wall that I just created, and I will create another wall for interior. Okay, I will change the function as well. And I have a few walls created, and now I will quickly sketch a building plan. So I will start from here. My wall will be, yeah, it's exterior wall, that's correct. So let's say 8 meters, then 12 meters, then 15. This one will be, let's say, 16, then 7 meters, and I'll just connect these. Then I will take my interior wall. Okay, it's this one. And I will continue by drafting a few more walls. But I forgot to edit the structure of this wall. So that's fine. I can do it right now. I will delete these 2 layers. I will delete this one. So this will be just the main frame and 2 layers of sheathings later. Okay, I will continue by drafting the walls, and I will keep these gaps. I will explain later why I kept them here. Okay, so just adding a few walls here. And now you can see that I have not connected these walls. And that is because we also recommend to have only 2 walls connecting in one place. That is because the software needs to identify what kind of connection that is, whether it's a T connection, start or end connection, this will be the L connection, and you can see that these walls are connected. I can disallow them, but I will not. I will keep them connected in an L join. I will disconnect these walls. I will disallow join for them, and now I will connect them, so I won't have any issues while framing. Okay, that's it. And I will align a couple of more walls so that the plan view would look nicer. Okay, let's say that's it. Okay, then I will add a couple of doors. So the structural framing software will identify all of the openings that are added to my project, and it will frame these openings based on the rules that I create, so based on the configuration. And I also can add some openings, so windows. I will take maybe a larger window like this, and I will just add a couple of openings. Okay, let's say like this. Okay, and now I will make sure that all of my walls are going up to the second level. Apply. So let's see how the 3D model looks like. And it looks okay. So now I will also make my walls transparent so that later when I will distribute structural framing elements to them, they will be visible more clearly. So also, the size of the wall is really important because if I want to create prefabricated panels, I have to split the walls into the correct size before framing them. So the wall has to be the same size as the future prefabricated panel. And you can clearly see that these walls, right now, they are too big. So I will go back to the plan view and I will split them. So we can split them using Revit, modify, and split elements. So I can just go ahead and split my walls like this. For example, I will split this here and this one here and so on. And I can just go on and split all of the walls in my project like this. But also we can split these walls automatically using our tool that is called Smart Walls. So in the Smart Walls, we have a couple of settings in the split wall menu that you can adjust. So in these settings, you can add offsets from the openings, you can fit the opening in the complete segment, and you can define the size of your panels. So once all of these values are entered, we save it. And then we can split the walls from end, from start, or from picked end. There are a lot of options to split them. So let's say that I will split these 3 walls from the start. I will hit escape. And you can see that all of these walls are now split automatically according to the settings that I just created. Yeah, so you can also use split walls with our Smart Walls tool. Okay, so now the walls are split and all of the connections are correct as well. So these are my L connections. The software will also identify whether the wall is shorter or longer in the L connection. So in the Modify tab, you have an ability to modify that as well. In the Geometry Wall Joints, I can click on it and you can see that I can change the wall joint. So that's important because the software will identify the longer and the shorter walls. So I have this connection created correctly. All of the T connections are here. I have some free start connections. So everything will be framed as I will predefine in the configuration. And that, I think that's all that I wanted to say about the modeling recommendations. And I will just quickly lower my level a little bit like this. Okay. So now I will quickly open my slides again. And right now, we will talk about the essential steps that you need to make before actually framing the walls. So you have to load the families into the project. You can locate the framing configurations, and then you can create a wall, floor, or roof link. So first of all, I would highly recommend you to visit our eHelp page before using our software. Because in the eHelp page, you will find a lot of useful information about the software, like technical documentations where a lot of features are described. Also, you can download sample and template projects and start framing on these before framing on your own project. And also, you can watch some webinar records where a lot of features are also shown in action. So before using our software, you will have to load the families. Because in this project, I don't really have, I will show you, I don't really have any structural framing elements. I don't have structural connection elements. So our software comes together with a set of sample families. And now I can load the main families. I have to also load sample details. These are structural connection elements if you need them. Then the schedules can be also loaded, and also the tags and the siding families. All of the other ones are optional if you would need them for more complex situations or for log houses, let's say. So once I've clicked on them, I can click OK, and that's it. Right now the software is loading all of the structural framing, structural connection families, and also the schedules. So now we will have them in our project and we will be able to frame using these families. Okay, and that's it. The families are loaded. So you can see that now I can see them in my project browser under structural framing. These are all structural framing families. You can see the types that I have. All of these elements are parametric, so you can very easily duplicate any of these elements, then you can rename it and create a new size for it. So let's say I just modified this element type, then I will go to the type properties and modify the actual value. And that's it, I have a new type. So you can very easily expand your library and then use these elements in the framing configurations. We also have some structural connections loaded that I will show you later, and also the schedules. So these are the template schedules you can modify as you can modify regular Revit schedules. They will be used for the shop drawings later. Okay, so now once we have the families loaded, the software also comes together with a set of sample configurations. So in the configuration files location, you can see that now I have the default path for the configurations. So just know that this is where they're held. It's just a folder that you can find on your machine. You can place it on a shared location if you'd like that, so that all of your colleagues could access these configurations. You can share it with others. And now once we loaded the families, we have the configurations, we can create a wall link. So now if I would select this wall and go to the link wall, in the first three columns, you can see the structure of the wall that was created in Revit. And now I can map a framing configuration to each layer. So first of all, I can predefine the framing layer type, and the structure of the wall will be, of course, the main frame. Then to the exterior side, I can also add, let's say, the sheathing, then horizontal nailers, and vertical siding. So again, this is just an example. You can create your own wall structure. Yeah, and here again, I will have the sheeting. And now I need to map the framing configuration. So as I mentioned, the software already comes together with a set of sample configurations. So you can use them, and you will have them also, of course, if you just download a trial version. So notice that I mapped these framing configurations, but for the sheeting, I cannot do that. That is because the sheeting layers are not framed. The sheeting layers are split. So we're splitting parts and creating the sheeting as parts category in Revit. So I will turn on split parts tick mark for them and assign a sheeting or paneling configuration in this column. And also I have to remove exclude parts tick mark because I don't want to exclude the parts in these layers. As I need them, the sheeting will be created as parts. So once the link is set up, I can save it. Okay, and now that's it. We can frame the walls. So I will open my slides again. So we already made the essential steps before using our software for framing. And now we can automatically frame the walls. So I will show you how we can create or modify framing configurations and frame walls, floors, or roofs in the project. Everything that I'm showing you right now is on the walls, but the process is the same for the floors and for the roofs as well as for the metal framing software. So right now, I will quickly frame maybe these two walls. So you will see that we don't really need to change the configurations. We can just test out the sample ones that we already have. So basically, once the rules are already created, you can see how fast it is. I just need to click on frame wall and that's it. All of the elements are automatically distributed to the model. So it identified the opening and framed around it. It identified this T connection. You can see I have these elements added here. I have the bridgings, the plates, and so on. And now let me show you where this configuration is created, and it's created in the framing configuration window. In this window, you can see that first of all, we can choose the configuration type, whether we want to create a rule for the mainframe, nailers, or sidings, and so on. So I'll choose the mainframe, and then the configuration name. So right here you can see the sample configuration that is loaded together with the software, and you can save it using your own name, make all of the modifications right here, and then use it in the future. So that is what I'm going to do. I will create a new configuration. So now you will see that I have another one, and I can modify all of the rules based on my own needs. So basically, in all of these configurations, we can choose an element type for each situation and how it's added. Set up a rule. So in the vertical stud tab, of course, I can predefine a stud type that will be added as a vertical stud, and right here I can add a spacing. Then I have the top plates. So again, I choose the element type that I need. I can add an amount of top or bottom plates. I can add 1 or 2 or how many I need. The same thing goes for the bottom plate. And I can also add offsets around my frame. So each layer can have a different offset. And now we have opening framing. We can create different rules for different opening categories like windows, doors. Opening framing is for system openings, generic opening families in our model. And then we have configurations for openings that are close to each other. These are all very similar, so let me show you the window framing. And here you can also see that we can create rules for non-structural and structural walls. And for openings, that are different sizes. So if the opening is smaller, I can use one rule. If it's larger, I can use another rule with a stronger header or something like that. And let's see what we have here. So again, we have sample configurations for framing the openings that you can save using your own name and then modify them. And in these configurations, again, it's a very similar process. These are all of the elements that can be added around the openings, like king studs, headers, sills, we have trimmers, cripples, and also we can add offsets around the openings. And in all of these situations, the process of creating the layouts is very similar and almost the same. So here you can see that I have this default configuration that I can duplicate, I can rename it, and then modify it. So I can remove an element after I select it. Once I select it, you can see it turns blue in the preview. I can add another element, choose a different type. I can rotate this element, align it to the internal side of the wall. I can add another one, again, choose another type if I need to. I can align it to the external side of the wall this time and to the previous element start. And I can just keep adding elements like these, and once I reach the result, I just save this configuration to the database, and now you can see that I can choose between the configurations that I have, so they need to be created only one time. And the process is almost the same for all of these windows. So once we have the rules set up, we just save this configuration and we make sure that the correct one is mapped for the correct opening size. And then we have connections. So as I mentioned, the software identifies the connections from your model, so it's important how you model them. Then you can set up the rules right here and everything will be framed according to your needs. So we have separate tabs for L connections, End connections, V connections, and T connections. And again, right here you can see that the process is really similar. We have an outer corner, L wall, and B wall. So L wall is the longer wall in the connection, and the B is the shorter wall in the connection. The outer corner means that this is the interior side of the building, and then we have inner corner when this is the exterior side of the building. In the connections, we can also create our own layouts or add extensions. The same thing goes here. Free start and free end is for walls that do not connect with other walls. Start and end connections are for the walls that are split. Then there's the V connections and T connections for intersecting walls. Then we can add ridge studs, and blocking and nogging is for horizontal elements in our frames. So these elements right here, you can see they're added as short elements between the studs. So for my interior wall, let's say I will map this new configuration and I will change the rule of the bridging. So I will keep this element type, but I will rotate it and I will align it to the internal side of the wall. And also I will add another element. I will not change the type, I will keep that. I will add it to the external side of the wall and to the previous element start. So you'll see that I have this double bridging. Array it from the bottom, we can also array it from the top, make it grow throughout the whole wall or only for openings and so on. So I will save this, and now for the interior walls, I will change the link. Okay, so I will say that I want to use the configuration that I've just created for the interior wall. And these two will be sheathing layers. So yeah, I'm doing the same thing for the link as I showed you for my exterior wall, except that I'm using this new configuration that I slightly modified. And now I will frame these walls and you'll see the modified bridging. So again, once you have the rules already created, the process is really fast. With our software, you just need to spend a little bit of time up front creating your own standards, but everything is really flexible and user-friendly, so you can create your own standards and then use these configurations from project to project. You need to create them only one time. Okay, and I will also frame a few exterior walls as well. Right now, I'm framing them with the sample configuration that I mapped in the beginning. Yes, so that's it. You can see that this is the longer wall in the L connection. This is the shorter one. I have the T connection there and here. These are again the L connections, and everything is framed according to the rules that were created. Okay, and now we just framed these walls, and if the frames are correct, you don't have to modify them, but I also want to show you that we have a lot of possibilities for modifying the frames. So we can modify them in a lot of different ways depending on the situation and depending on what we need. So we can modify the architectural model and then update the frames. We can modify the configurations as you just saw me doing. We can also modify only the selected wall or selected opening frame, and we can add additional elements to our frames. So let's take a look at that. Okay, so first of all, we can modify the architectural model. So let's say that another opening was added or an existing opening was moved, the wall became longer or shorter or anything like that, and the frame is no longer correct based on the architectural model. Anytime we can use update frame, and that's it. All of the elements in the selected frame will be updated according to the changes made in your architectural model. Also, anytime you can modify the framing configuration, and then you'll have to use update by wall link to update the changes made in the configuration. And also sometimes you may need to make a change only for one instance of the panel or only for one opening. One or two openings maybe, or one or two panels. In that case, of course, you don't want to modify the whole configuration. You want to modify only this opening or this frame. So there are possibilities how we can do that automatically. So let's say that I want to modify the frame of this wall. And now I will have almost the same window as we saw in the framing configuration, so nothing new to learn here. Now I can modify this frame. And let's say that I will what can I do here? Maybe I will add another row of bridging. So I will say that I want to have 2 rows, or maybe no, I will add 1 row, but the offset from the bottom will be 500, and I will add another area. I will say that it's from the top. The offset from the top is also 500, and I want to add 1 row. Okay, so now I'm modifying only this instance. The configuration right now is not changed. For all other walls, it will be kept the same. Okay, and this wall is modified. So now if you wanted this change to happen only for this wall, that's fine. But you can also actually save these changes to a new configuration if you'd like that. So you can use save configuration without openings, select any element from the frame, and you can create a completely new configuration that will not rewrite this one, but I will just rewrite it. Yeah, it tells me that it will modify the configuration with that name. And now when I will frame the walls that have this configuration mapped in the wall link, they will be framed with the changes made. Yeah, and that's it. You can see that I have 2 bridging rows in these walls. And also we can modify an opening in the same manner. We can modify the opening or the wall joint or joint openings. So let me show you an example with the opening. I will now select the opening, and you can see that again, I can change only the instance of this opening frame or the whole configuration for this opening. So now very quickly, I will just add another element for the header. I will rotate it and align it to the internal side of the wall, and that's it. A header above this opening will be modified. Everything will be cut correctly because we're making these modifications automatically. Yeah, and that's it. You can see now that I have an L-shaped header above this opening, and this one was framed by the configuration. Also, we can add additional elements to our frames. So if I, let's say, need to make my frame stronger in some locations, I can add additional vertical or horizontal elements by using the add or modify elements functionality. So let's say that first of all, I will add some horizontal elements between these 2 studs. So I will say that I want to add short elements between the studs. I will align them to the internal side of the wall. I will cut the bridging. I will add 2 rows, and this is the offset from the bottom, and this is the spacing between the 2 rows. Okay, and that's it. You'll see that horizontal additional elements will be added between the studs that I just selected. And here they are. And in the same manner, we can add additional studs. So I'll select this stud, and I will add my additional stud to the right from the selected one, and I will actually make it a double stud. So the distance will be the same as the thickness of the stud itself. And you'll see that now I'll have a double stud created in this location, and again, everything will be cut correctly. And I have a double stud. Okay, so there are actually a lot of more ways how we can modify the frames. We can align elements, we can cut, delete, move, and rotate them, trim and extend them, and split them. So it all depends on the situation that you want to reach. And now, let's talk about other layers. So let's say that we've already created the main frame and we have reached the result and we're ready to frame all of the additional layers and add details maybe, so structural connection elements. So let's see how we can add those. So first of all, we also have a possibility to distribute structural connection elements. They were loaded with the load families command previously. So we have a few configurations, a few sample configurations for the details here as well. You can see the rules, how they were created. And now I can simply use add details, select any element from the frame, select the sample configuration, and structural connection elements are distributed automatically. So these clip angles are added to the left and to the right side of the stud. On the bottom plate, I have these balls added in the middle between two studs, and so on. So you can also create your own configurations for the structural connection elements and use them in the future. And also, I can create other layers like secondary frames, sheetings, nailers, and sidings. So sheeting or paneling layers are actually created right here, the rules for them. So in the sheeting configuration, you can see that you also have sample configurations that you can duplicate, save, and use in the future, share it with your colleagues, add it on a server, and use it in your future projects. So here you can predefine the maximum size of the sheet, and then a sheeting layout, whether they're parallel or perpendicular to the studs. You can add extensions from the bottom or from the top. You can split them from start or from end, from both sides, merge them, split them near the openings, and so on. You can add offsets around the openings or offsets and extensions for various types of connections. So it's really easy to understand. Once you make the changes, you save them, and then you can select the walls that you want to split parts for. So let's say that from now I will be working with these walls. So I will split the parts for them and also maybe for a few interior walls and use split parts. So with this command, the tool will split the parts for the interior and exterior sheeting layers. And we will not be able to see the parts once they are created because we have to turn on the parts visibility in order to see them. So they're already here, but I have to turn on show parts, and that's it. You can see that for the walls that I've selected, the parts are split according to the settings in my configuration. They're also, of course, aligned with the studs automatically, yeah, and they're staggered also. The same thing for the interior walls. Okay, and now I can go back to the original view and frame all other layers. I can frame them all at once, but for presentation purposes, I will show you them one by one. So first of all, I will add the secondary frame to the interior side of my wall. As I mapped in the wall link, all of the elements will be automatically aligned to the main frame. Okay, and that's it. The secondary frame was added, so you can see it right here. All of the elements are automatically aligned with the main frame. Okay, and now let's continue and add the nailers. So now the tool will distribute horizontal nailers on the exterior side of these walls. So again, I'm using sample configurations. You will have them as well. You can modify them and you can see how fast it is once the rules are already created. And you have to create them only one time before starting on your first project. And then that's it. You can use them in the future. And right now I'm adding the siding. So this is the final layer of my wall, and the modeling part for these walls is complete. So I will be ready to number the elements and to create the shop drawings. Okay, and that's it. The panels are complete. you can see that I have all of these layers framed automatically according to the created rules. And now, before creating the shop drawings, we will need to number the elements. So we will need to number the walls, structural framing, structural connection elements, and parts. And later those values that will be entered automatically with the software will be visible in the shop drawings, and also they will be used in the schedules to calculate all of these elements. So this step is really important. And with the software, we also have numbering configurations. So they come together with the software. You have them as sample configurations. Of course, you can modify them as well. And with these configurations, we can modify the walls, then the parts for the sheeting or paneling layers, and then, of course, structural framing elements and structural connection elements. So this is all set up. It's a default configuration that you can, of course, modify. All of these can be modified as well. And now, once they're set up, the first step that we have to do is we have to number the walls, because then all of the elements that are inside the walls will inherit the mark parameter value. Also, the assembly name will be the same as the wall mark. So now, in just 1 second, all of the walls in my project were numbered. So now if I would select any wall, you can see that it has a mark parameter value. So this is a wall number 3, for example. This is a wall number 1, and so on. And now we can continue by numbering other elements. So now it doesn't matter which goes first. Let's say I will number the parts, so the sheeting elements, and now I will number the structural framing and structural connection elements that were added to the model. So now this functionality needs to be used only one time after the project is complete. It will number all elements in your project. It needs to be used only one time, and all of those values that are being written in the elements right now will be visible in the shop drawings, and they will be also used in the schedules to calculate all of these elements. Okay, and that's it. The elements were numbered, so we can take a look. I will select this stud, for example, and you can see that all of this information was just filled in automatically. So this element knows that it's a stud, that it's a vertical stud, number 1, inside a wall and inside the main frame. Also, it knows its cut length, and it knows that it's located in wall number 16. And the same thing goes for all elements. They were all just numbered. Okay, now when we have the elements numbered, we can move on to actually creating the shop drawings. So right now I will show you an optional step how we can transfer project standards from one project to another, because in my case right now I've just started from an empty Revit template. I don't have my own templates so that the views would look nice, the scale would be correct. So I will transfer the project standards from our sample project, and also I will show you how we can create or modify drawing configurations, then finally create the assemblies and set up a sheet template. Okay, so first of all, again, I will open this project, and you can see that I opened it from a standard Revit template. So I don't have any templates, I don't have any maybe suitable dimension styles or anything like that. And for this step, I sometimes recommend to take our sample project from the eHelp page, so you can download this project and take all of the view templates from there. So I have opened that project right now, and if I would take a look at the sample assemblies, you can see that these views look pretty nice. Of course, you may need to change something. You can use your own templates, of course, if you do have them, but if you don't, you can take all of these standards from our project from the eHelp page. So right now I will open my project again. I will go to Manage and Transfer Project Standards. So in this window, I will choose the sample and template project downloaded from the eHelp. I will use Check None, and I will transfer the dimension styles. Then also I will transfer filters from that project, then text types, and also view reference types, templates, and viewport types. Okay? And that's it. All of this information will be loaded into my project. And if you have your own project template, of course, you can use that. That's it. All of that information was transferred, so now we can create assemblies. And before that, I want to show you where we can set up what kind of views and schedules do we want to create. So we have a drawing configuration, and again, we have a sample one created already, so you can use that. So this is a few of our configurations. And I will choose the vertical siding one. So you can see that here you can predefine what kind of views do you want to create. Whether it's a 3D view, elevation front or back view, you can write any kind of name in that view, choose a framing layer that you want to see in that view, whether it's sheeting layer or frame layer. This layer will also be automatically dimensioned and tagged. Then you can see that I have those view templates that I transferred from my template project. I can assign a dimensioning rule. These rules can be modified. The tags were loaded with the software automatically by using load families command. And then I can create schedules where all elements will be automatically calculated. Again, here we're using our schedule templates that were loaded automatically with load families command. So it helps a lot. You don't have to create your own from the beginning. And then we can create sheets. So we can create any number of sheets, but in this example, I will create one so that it would be faster for me. So when these configurations are created, we save them. And that's it. Now I can use create assembly, select any element from the frame, then a configuration, and now you can see that the tool is creating an assembly for wall number 1. So this will be the same, the assembly name will be the same as the wall mark, and that's it. I have my first assembly. You can see for wall number 1, and I can find it in the project browser under assemblies. So this is the one for wall number 1. Okay, and you can see that I have a 3D view, I have an assembly front view, I have a detail section view. You can see all elements are automatically dimensioned. Then I have the frame front view, again with the dimensions added automatically. All elements are also tagged. So this is the bottom cripple, the vertical stud, king stud. I have the header plate, the top plates, the gravity point is here, and I even have separate dimension strings for openings. Then we have a view with the sheeting, and you can see how nice it looks. I can see the frame behind the sheeting. It's also dimensioned, and this is again a view template that I took from our sample project for the sheeting, where parts are unhidden. Then we have the plan detail, view with horizontal nailers, a view with a secondary frame, and vertical siding. Finally, we have the schedules generated where all elements in the assembly are calculated. Then we have schedules for individual layers, like for the frame, where we can see the sort marks, the elements are calculated, the cut length is here, the framing member mass. We have the schedule for horizontal nailers, secondary frame, and sheeting as well. And then finally, we can create a composition on the sheet. So I can drag and drop some views. So I can say that I want to have, let's say, the frame front view, then the detail section view, and the framing plan detail also, let's say, oh, not this one, the schedule for the frame. So this will be a pretty simple template. And now I can say that this sheet should be used as a template for the future. So I can go back to the drawing configuration, and I can say that this sheet for wall number 1 will be a sheet template from now on. So now I can just select all of the walls, let's say, that I've created, click on create assembly, and that's it. Not only all of the views and schedules will be generated automatically as they just were for wall number 1, but also the sheet will be generated as well with all of the views placed in the exact same locations as I placed them on this first sheet that I set as a template. And we don't even have to actually create this first one because we can set up a template project. So if we do have a template project, then we won't even have to create the first sheet in the project. Okay, and I have another assembly for wall number 13. So let's take a look at that. And again, of course, we have all of the views: the 3D view, assembly front view, frame front view, and so on. So everything is the same as before. Also, I have the schedules, but this time I also have a sheet. So previously we created this sheet, and now a sheet for this wall is generated automatically, and the views are placed in the exact same locations as I placed them on this sheet. So from this point, everything will be done automatically for you. Okay, and now I would like to encourage you to download a free trial. So you can go to aga-cad.com, choose a product that you're interested in, and click on free trial. You will be able to download a Tools for BIM doc for the Revit version that you're working with, and from the Tools for BIM doc you can watch this short video explaining how it works. You will be able to download the trial versions of our software and try them out for yourself. As I mentioned, you will have the families, you will have the configurations. Now you know how to start from an empty project, so you can do that, or you can download our sample project from the eHelp page. And yeah, thank you everyone for attending this webinar. I hope that you found out something new and beneficial, and I also hope to see you in our future webinars. Have a nice day.
aga-cad, building BIM together.